record this one because Joey's not in here. So, okay. So today we're going to start with ellipses. Okay. So I found this website that shows you what an ellipse is. An ellipse is a curved line forming a closed loop. See, I don't like that already, even though but it gave me this cool drag this orange dot anywhere type of a thing. Oops, except hold on, tap the brakes. So it's a closed loop where the sum of the distances from 2 points is the same for every point on the curve. So as you, oh, I gotta get back to the point, there it is. So as you drag this point around, the sum of the red line and the blue line is always the same, okay? And it's actually the length of the major axes. Okay? And we'll talk about that here in a minute. But that distance is always the same. Okay? They can't obviously see this on the interwebs when you're watching the video, but over here we have a cruder version of that. Okay? This green length here on this string is always constant. Okay? The sum of the 2 parts of the green string are always constant, and when you go around, that's how you make your ellipse. Okay? And then these 2 screws would be the foci. Yes, ma'am?
Do we need graphic paper today or no?
I don't think so. I don't remember. We might need one. Okay. Alright. The equation for an ellipse is that x minus h quantity squared divided by a squared plus y minus k quantity squared divided by b squared equals 1. It will always, an ellipse, always equals 1. Okay? There is one condition with an ellipse, and that one condition is that a in that equation cannot equal b. Because if a does equal b, then it's just a circle. And we're taking a circle and we're stretching it out in one direction, either horizontally or vertically. That's what an ellipse is. Okay? Some examples of ellipses. Planetary movement around the sun. Okay, so Earth's orbit around the sun, and any planet's orbit around the sun is an ellipse. If you take, for those of you that have water bottles or water glasses, I don't know if I have any glasses on the desk, but if you tip it to the side, you tip it at a little bit of an angle, the surface of the water becomes an ellipse. I forget what museum that one on the right, on the upper right is, but that roof is an ellipse. The one on the lower left down here, it's actually got a cool story to go along with it. This is the hall in the U.S. Capitol building. It's elliptic. And it was in this room that John Quincy Adams, while a member of the House of Representatives, discovered this acoustical phenomenon. Okay? So he put his desk at one of the foci. So the room here, if you look at this ellipse over here, the room was elliptical in shape. He put his desk on a foci, okay? On one of them, okay? On a focus, I should say. One of the 2. Focus is the singular, foci is the plural. Okay? And he was able to very easily eavesdrop on every single conversation that was going on in the room. Because it's one of the cool things. Sound is a wave, right? So if I'm talking in this direction, okay, that sound is going to bounce off of the back wall, and it goes through the ellipse, or through the foci, because it's elliptic. All of the foci is here. So if I'm standing here, and I'm talking, this both foci get it off of the bounce. Pretty cool. The one on the right then is St. Paul's Cathedral in London. Sometimes I know the Science Museum in St. Paul has a room that's an ellipse, and you can stand in one spot and you can hear any conversation going on in the room, kind of a deal. So there's all different kinds of ellipses. Okay? So that's an ellipse. Okay? We are going to graph that ellipse right now. Okay? So we're only going to graph one graph today. Okay? These steps that we're going to go through will be extremely beneficial for you in graphing ellipses from here on out. So, let's do it. Okay? The first thing that we want to identify is the center of the ellipse. Okay? And that is identified just like it is with circles. Okay? So, what would the center of this ellipse be? It'd be at the point what? 3, negative 2. Okay? So the center here is located at the point 3, negative 2. We look at the x, think oppositely because it's in parentheses. We look at the y, think oppositely because it's in parentheses. So the center of this ellipse is at the point 3, negative 2. Okay? That one shouldn't be, by now you should automatically be thinking oppositely anytime it's in parentheses. Okay? So let's graph that center. So the center is at the point 3, negative 2, and I'm just going to put a C on there for it. Okay? I'm just going to move my ellipse up closer so I don't have to keep walking back and forth. Okay? So the center is that point right there. Okay? It's not really part of the ellipse, which is why I just mark it with a C. Okay? Step 2 says, now I am going to look under the x squared term. I'm going to take the square root of this number, and that is going to be the end points going to the right and to the left because it is underneath the x. X is left and right on the graph. So the square root of 9 is 3. So I'm going to put points 3 spots to the right and 3 spots to the left on the graph. And those points are on my graph. Those are points that are on the graph, or on the picture of the ellipse. Okay? What do you think I'm going to do next? Based off of what we just did. Matt? Going to look underneath the y squared, and that's going to tell me up and down. Yep. Okay. So let me get you back to situated. So there's my center. 1, 2, 3. 1, 2, 3. Okay. So now I'm going to look under the x or under the y squared term. Take the square root of this number, and that gives you the endpoints going up and down. So the square root of 16 is 4, so I'm going to go up 4 and down 4. Ellipses are ovals, yep. Okay? And that's the framework for my ellipse. So now I can draw that in. So now we've drawn in our ellipse. Now, since I drew it so good, okay. The last thing that we have to find are the foci. Okay. Foci is the plural of focus. They are located along the major axes. Which is the major axis in this one? The horizontal axis or the vertical axis? Why vertical? Because it's bigger. Exactly. Okay? You've got ellipses have two axes. They've got a major axis and they've got a minor axis. Okay? And I can't tell you that the vertical axis is always the major axis because it's not. Okay? It's whichever one is longer. That becomes the major axis. Okay? So in this case, the vertical axis is the major axis. The horizontal axis is the minor axis. Okay? The important formula for foci is that red formula. A squared equals b squared plus c squared, where a squared is defined as the bigger number under either x or y. Whichever one of those is bigger is the a squared. The other one, then, is b squared. Okay. C is defined as the distance from the center to a focus. Okay. So in this case, in this ellipse's case, C is going to be how far up we go to get to the focus and how far down we go to get to the focus. Okay? Because there are two of them. So, which one is a squared in this case? The 16 is a squared, and 9 then is my b squared. So I solve that. So I get 16 equals 9 plus c squared, which then would give me 7 equals c squared, which gives me c is equal to the square root of 7. That is going to get added and subtracted to the y of the center, since the bigger number was underneath the y. So the two foci are located at the points 3, comma, negative 2 plus the square root of 7, and 3, comma, negative 2 minus the square root of 7. So on my graph, the square root of 7 is what? A little bit bigger than 2, not quite 3, right? So I'm going to go up 1, 2. Right there would be a focus. Right there would be a focus. Okay? So I would put those two on my graph also. To see what it is. Bottom 1, 1. The point? Because I have to add the C value. You understand where I got the C value? By solving this equation for C. Okay. I have to add that because my major axis is vertical. I'm going to add C to the y part of my center. Gets me this one. I'm going to subtract C from the y part of my center. Gets me that one. Okay. So this point here is the point 3, comma, negative 2 plus the square root of 7. This one down here is the point 3, comma, negative 2 minus the square root of 7 from the center. That's where you start. Start at the center. Yes, ma'am.
So if the oval is like a long oval like this, are the focuses
Foci.
always going to be like on the long end?
They're going to be on the major axis. So if this were tipped over on its side, so it was like this one, okay, I would add and subtract C to my X part of the center. Okay? With me?
Yeah.
Okay. If this were a horizontally stretched out ellipse, there's my center. I would add the C value to my X part and subtract it from my X part. Y would stay locked in. Okay? Because your foci, you should probably write that down. Your foci are always on the major axes. Okay? Foci are always on the major axis. Vertical is Y. Has been forever. Horizontal is X. Okay? I know, I'm seeing if I need to go here or not. Oh, whoa, tap the brakes. No idea what that is. 5, 6. Nope, I don't have to. That's tomorrow.
So do we have homework?
Not until tomorrow.
Okay.
Yep. Get rid of that. Get rid of that. Any questions on ellipses?
Pretty straightforward. Like a circle, but not.
But stretched out. So the only other thing, because this just popped into my brain, okay, the only other thing is I may ask you, wink, wink, nudge, nudge, I may ask you for the length of the major axes and the length of the minor axes. Okay? So in this case, the length of the major axes would be 8, because it's 4 up and 4 down. So the length all the way across is 8. The length of the minor axes would be 6, because it's 3 left and 3 right. Okay?